Hi, welcome back. So as promised, I modified the Freakonomics short .wave file. So it's not only a minute, I extended the period a bit so that we have multiple speakers actually. So using that file, let's now do the inference. So let's first load the code, then do the whisper inference. Let me close the file system here. Okay, afterwards then we'll get the access token and apply our model, and then let's quickly inspect the output of the model, and then let's see what we can do with that. So Whisper is still running. Actually, it pays off if you have a GPU, which I don't have at this machine right now. So it takes a while. Alright, then next thing will be the diarization, and this will also take a bit. You can also pause in between. Alright, we're finally back. So it took actually longer even than Whisper. So this is the output from the diarization object. So if we inspect it, type diarization, then you can see it's this class here, and if you kind of just enter it, then you get actually this nice chart. So it shows you, I'm not sure how, okay. So for the 200 or so seconds that we have, it tells you which speaker was detected. So in the beginning, a long time, it's more or less a monologue, and then another speaker chimes in, and here we have a minor overlap, although this is a very, very tiny speech segment. Okay, this output, this object, we could write into a RTTM file again, like we did last time. If we look at it, the RTTM file, then that's what we see. So kind of that's the name of the file, here are the different speakers, and these are the periods. I don't like the output format too much because I'm actually very used to comma separated text files, and so I think what I would do now for further data analysis, I would actually transform this output into a regular pandas data frame and also just capture those columns that are relevant to me. So let's do that. So we have our diarization object once again. That was very unclever. I need to rerun it. Sorry for that. And annoying mistake on my end. So in the meantime, I already went to the GitHub page of pyannote, and there's this apply pre-trained pipeline notebook, which shows us how we can deal with this diarization object. So here we kind of, if we apply the pipeline, we get this diarization output, and this is how we loop over the individual rows, so to speak, of the RTTM file. So let's just copy that over, and okay, I can only close that window. So for speech turn, track speaker in ether, so this is diarization for us, and then we could print it. Let's see what we get when we do that. Okay, we get kind of these entries printed one after the other, and if we want to inspect just kind of one of such objects that we iterate over, then the speech turn is actually, it shows us here this first segment, and it should come, as we can see here already, with certain properties. So there's a speech turn.start, which is the starting time, and a speech turn.end, which is the end time. We can also see we should probably round it, and then we get also the speaker is what we iterate over, and the track is, yeah, it's basically a numbering. So in index, it's not 1, 2, 3, but A, B, C. Okay, so then let's try to get our data frame. So we need definitely a pandas data frame, but for rounding, I think we also need NumPy. And then, so this segment info is, let's make it a dictionary and then transform it into a data frame. And so we could say start is speech turn.start, correct? End is speech, nice auto completion, and speaker is speaker, that should also work. And then PD data frame from dict is df. And we should round those numbers, so np round, let's make 2 digits, np round 2 digits, then we don't need that line anymore. Let's this data frame from the, okay, it's generally a problem if we just put that dictionary in here like that. So let me show you the dictionary. Okay, we also need to provide somehow an index so that it gets interpreted correctly, and for that I think we can just use the iteration here, the track, and I probably need to also modify the orient to index, but that's something I always need to try. Okay, that looks good. So we have it as a row, so horizontally, not vertically, otherwise we would have numbers and a string mixed. And so this, we need to keep track of all these segments. So segment info list is a empty list, and segment info list append this df. Then let's get rid of this, and in the end we need to concat all the elements in the list, and this is all segment infos df. And then let's see. Okay, that looks pretty much as what we want to have. Let's put it into a function. So that will be the high level function, because I think we should just always try to get to a formalized output, and the formalized output as we defined it will be just a data frame that we can easily get to CSV. Let's quickly look once at the sec df data frame. It has some index which is named. Okay, because if we write to disk, we always need to think about whether we should also write the index or not. Okay, and here we probably want to give this a column name as well. So I would can immediately do it. What is if we do it like that? Okay, index. That looks actually nice, and then I would write it to disk without the index, which I usually prefer to do. Okay, then the Whisper application was inference with segments df. So let's try to be somehow consistent. Def pyannote inference df, so that we get back a data frame. And what do we need as an input? Okay, file, and so all of that should be in there. Now let's make 2 things out of it. First is def, let's call it rttn to data frame, or diarization. Station to data frame. This is the diarization. And then we have all that in there, which should work, and then return all sequences df. And then we want to call it, then let's make it like that, and we probably put it to the model, so pyannote wrong indenting, so from source model pyannote import what was it called, Diarization to df. Okay, that's surprising, probably because the module was already loaded. Okay, I clean that up, and also will put the diarization and the diarization to Dataframe part into a function so that we have this cleaned up, and it will need as input some file name and pyannote token, and then we get the token from outside, fname, and then I'll rerun it, and then we can look at the outputs, and I'm looking forward to that. df. Okay, I'll make a stop until then. Alright, done. So I kind of created a new function, the pyannote inference data frame. So this is just where we apply the model and then transform the output to a data frame. I called the function here, and now this is the output that we get. So it's a diarization data frame, and yeah, how we wanted to have it. And the other thing was from Whisper, the output is this, where we also kind of get a lot of segments, because it's not only one row when another speaker enters the conversation, but whenever kind of, yeah, more or less every sentence in there. Here we also have start and end, then we have the text, and in the end we now need to combine those two CSVs and kind of make sure that we find, yeah, for the segment from 5 seconds to 109 seconds where speaker 00 is speaking, we need to find all his sentences, and I think that's more or less the idea. Kind of when we move to this data frame, what we lose a bit is the nice chart that we could create directly from the diarization object, because if we want to get that, we first would need to translate this data frame back into a diarization object so that we can apply the .plot method. But I think yeah, for going forward, it's fine if we work with the CSV files alone. And maybe one more remark, kind of why don't we put the token, why do we kind of keep it outside of the main function? So would it not just be more convenient if we kind of have this inference function and it only has a certain file name as input and not a token, that we kind of externally all the time need to define where to get it? Yes, it would be more convenient, but it's also, I think, if we would share the code with other people, then it's pretty clear that people will host or maintain their token in different files, and so we cannot really hard code a path here. That's why it should be an input, in my view, to the function, similar as the file name, because like file names also, the .wav file could lie everywhere on disk, and so yeah, those should be inputs. The logic is, however, reusable then. And, okay, so that's it for today, and now next part will be that we kind of combine those data frames. Till then, see you.